I've been interested in electric longboards for quite some time now, but their pricing has been a bit of a bummer. So in order to make it affordable, I decided to try building my own electric board. First thing to choose were the batteries. As pre-built battery packs tend to be quite expensive, I also decided to build my own battery pack. I chose the LG 18650 cell as it featured a good capacity of 3 amp hours and a good discharge current of 10 amps max. I created 3 battery packs, each with 6 cells in series, thus having a voltage of 25 volts, and with all 3 packs together a theoretical max of 30 amperes discharge. Each of those packs has its own balancing module and a protection circuit. This is important for the longevity of LiPo cells as they mustn't be overcharged or discharged. I used masking tape to insulate the contacts and try to hide my bad wiring. LiPo battery cells usually get welded together, but as I lack that equipment, I just soldered them. Extreme heat can damage the cells though, so be careful. The next key component is an electric speed controller. It converts DC to the needed 3-phase current. The speed of these phases can be controlled with a PWM signal created by a microcontroller. It also features a small 5V power supply to directly hook up the microcontroller. The microcontroller I chose was a ESP32 board, simply because my RF transmitter hasn't arrived yet and the VLAN was my only wireless option. But an Arduino Nano will do the job just fine in combination with a RF transmitter and receiver. My longboard had some spare holes, so I designed a crew casing around that. It's nothing more than a prototype, and when it's redone with a bit more love, I'm sure it will also look good, or at least better than this. I have installed a switch and an indicator LED in the case. Excuse me if the wiring triggers some OCD attacks. The 3 outputs of the ESC are fitted with quick connectors and lead outside the case to the motor. To connect the motor to the wheels, I used 2 gears and the HDD 5M belt. The orangutan kegel wheels already have 10 holes, so I just need to bore and tap them into the big gear. The main challenge was fixing the motor to the board. I first ground down the aluminium of the trucks and then created a crude mounting plate. I miscalculated my first drill and ended up with an extremely ugly piece. I will also recreate that part in the future. A screw is used to clamp down the mount onto the longboard trucks. With all that hooked up, the longboard is ready to go. With a top speed of 36 km per hour, the board is rather scary to ride at full speed. It doesn't struggle at all with hills. After a few days of riding though, I threw my board onto the ground out of habit. The thin plywood sheet sadly couldn't handle that impact. But let's be real, it might be better if this ugly piece is gone for good. I will do a part 2 with a better built design. Until then, and thanks for watching.